Hello everyone, welcome to C Patel Academy. In this lecture, I am going to compare the rate of Sn2 reaction. Before comparison, let's discuss about the Sn2 mechanism. Okay, Sn2, that is nucleophilic substitution by molecular reaction, is a one-step process, and if we take different alkyl halide, then the rate of 1 degree Rx is maximum, then 2 degree, then 3 degree. It means this reaction is sensitive to steric hindrance. It is inversely proportional to steric hindrance basically. More steric hindrance, less will be the reactivity. Now the rate law expression is rate constant into concentration of alkyl halide into concentration of nucleophile. So rate of this reaction depends on both the concentration of alkyl halide and concentration of nucleophile. It is a second order reaction with the order 2. Stereochemistry is inversion of configuration, that is backside attack of the nucleophile. Now it is favored by strong nucleophile and better leaving group. If we compare with the fluoride, chloride, bromide, iodide is the best leaving group, so the reaction rate will be fastest. Next, it is favored by aprotic solvent, that is aprotic polar solvent like acetone, DMSO, DMF, etc. So now let's move to the question now. Let's see. This is the first one. Which Sn2 reaction in each step, each pair is faster? Okay. We have two alkyl halide and the nucleophile is same. In this case, basically, we have the same nucleophile. Okay. Now, in the alkyl halide, in first case, we have bromide ion as the leaving group, next chloride as the leaving group. We know that leaving group ability of bromide ion is more than that of chloride ion. So in this case, the first reaction will be faster. Let's move to the next one. In this case, the alkyl halide are same. You can see identical alkyl halide, but the nucleophile is different. In first case, we have hydroxide ion as a nucleophile. In the second case, we have water. And since Sn2 reaction is favored by strong nucleophile, so this hydroxide is a stronger nucleophile basically. Hence, the first reaction will be faster. So we can say it is what? Stronger nucleophile. Now let's move to the next one. Yeah. In this problem again, we have same alkyl halide. Alkyl halide is same. So the rate will be mainly decided by nucleophile. In the first case, we have hydroxide ion as the nucleophile, and in the second case, this one is the nucleophile. If we see, the second nucleophile is simply acetate ion, that is O minus CO CH3. In acetate ion, this lone pair on oxygen is resonance stabilized, and due to this delocalization of lone pair and forming this resonating structure, nucleophilicity of this acetate ion is less. So it is weaker nucleophile, and the first one is stronger nucleophile. So in this case again, first one will be winner. In this case, you will be getting the faster reaction. In this case, you will be getting the faster reaction. Now, let's move to the next one. In this case, we have same alkyl halide as well as same nucleophile. You can say alkyl halide is also same and nucleophile is also identical. Now, the solvent will decide. In the first case, we have methanol. Methanol is protic polar solvent. It is protic polar solvent. And DMSO, that is dimethyl sulfoxide. This is dimethyl sulfoxide. This is basically aprotic polar solvent. And as we discussed, Sn2 reaction is favored by aprotic polar solvent. Then in this case, the second reaction will be faster one. So in this case, the second one will be the winner. Let's move to the next one. Now, in this case, the nucleophile is same. we have got the same nucleophile, that is ethoxide, that is strong nucleophile, but the alkyl halide is different. In the first case, we have 1 degree alkyl halide. This one is also 1 degree alkyl halide because this is 1 degree carbon. But because of this methyl group, in the second case, there will be steric hindrance. That is beta branching basically, and due to that steric hindrance, the approach of nucleophile to this carbon will be less. So in this case, I will say the first one will be the winner. Because of the steric hindrance, it will be less reactive, and here it is less steric hindrance, we can say less steric hindrance. So it will be faster reaction. That's all. Thank you.